let me take this out. We have been asked to calculate the relative molecular mass of a gas. So the gas, we don't know. If a given volume takes 60 seconds to diffuse through a porous plug, whereas an equal volume of oxygen takes 80 seconds. So there is a first gas which is unknown, let's call it X, and there is another called oxygen. So they say we should calculate the relative molecular mass, M1 of that gas, we don't know, so M2, oxygen is 16 times 2, which is 32. So we know that of oxygen. Okay, 60 seconds. It says calculate the relative molecular mass of a gas if a given volume takes 60 seconds. That volume, V1, and the time for T1 is 60 seconds. V2 and the time for T2, we don't know yet. Diffuse through a porous plug, whereas an equal volume of oxygen takes 80 seconds. Is it 80? Yes. This is 80 seconds. The volume too, we don't know. But the volumes are equal. If the volumes are equal, means they are going to cancel out. So they say we should find it. So starting with the formula, R1 over R2 is equals to the root of N2 over the root of N1. R1 is V1 T1 divided by V2 T2 is equals to the root of N2 over N1. And there I have V1 over T1 times T2 over V2 is equals to the root of N2 over N1. Now they say they are equal volumes. So I have T2 over T1, T2 over T1 is equals to the root of M2, the relative molecular mass of the oxygen here is 32. Why? That of M1, we don't know. So I have my M1. Okay, this is the same thing as T2. Let's put the time now. Now, the T2 is 80 seconds. 80 seconds. T1 is 60 seconds. This is equals to M2 over M1, making M1 is the root, of M1. So now to cross multiply, I have 80 root M1 is equals to 60. M2 is 32. 60 root 32. Divide both sides by 80. By 80, so this will go, I have my root of M1 is equals to 60 over 80, 60 divided by 80, 0.75 is equals to 0.75 root 32. To remove these roots, I square both sides. So I have my N1 is equals to 0.75 squared give me 0.5625 times 32, because the root of 32, the square of the root of 32 is 32. Come over here again. So my M1 finally becomes this times 32 times 32. I have 18 G mole or whatever it is. So that is the relative molecular mass of the unknown gas X. That of oxygen we could determine that. Okay, let's take another question. Am I clear? 60 cm cube of a gas A. So this is a gas A. 60 cm cube. So V1 is 60 cm cube of a gas A that freezes out in 8 seconds. T1 is 8 seconds. And 120 cm of another gas B, this is B, V1 is 120 cm cube of another gas B. Okay, that uses in 12 seconds, T2, 12 seconds. Calculate the rate of diffusion of the two gases. This is interesting. The rate of diffusion of the two gases. Remember, I told us earlier on in the formula section that rate is equal to volume over time. So I think this is where it comes. So gas A rate is equal to V A over T A, as the case may be, if I want to call it one or thereabout. So this is equals to, the volume is 60 cm cube, the time is 8 seconds. So this definitely is 60 over 8. Over 8, I have 7.5, so 7.5 cm cube per second. Gas B rate is equal to volume of B over the time of B, and this is equal to the volume is 120 cm cube over the time is 12 seconds, and this is equals to 120 divided by 12 is 10. So I have 10 cm cube per second. So that's that. Let's take another question. So the aim of solving a lot of questions is to give us different angles at which we can solve a particular question. So a lot of you use different textbooks, so probably in the textbook you're using, there could just be 2 exercises there, and in the course or your quest of solving it, you find it difficult because the 2 questions may not have covered everything. Probably even if you have to master the principle of solving those 2 questions, what about if you come across other questions in different textbooks with different methods or principles? It becomes difficult for you to solve them, all right? So I'm giving us a method, a generalized method, which if properly applied, you can solve questions from any textbooks. It wouldn't matter where the textbook or which textbook or the nature of the questions they're in. So let's take another question. How many times is the rate of diffusion of hydrogen? So I have hydrogen faster than that of oxygen. I have oxygen. And what law do you use to get the answer? The vapor densities of hydrogen. Vapor density of hydrogen is 1, and that of oxygen, density for oxygen is 16. You say, how many times is the rate of diffusion? First off, okay, let's start. This is rate for hydrogen, which is my arrow 1. This is my arrow 2, rate for oxygen. This equals to the root of M2, which is of oxygen, M1 for hydrogen. Remind me, I have to put it that way. Okay, rate of hydrogen. Okay, let's go back to this, guys. So let's maintain this rate of hydrogen over rate of oxygen is equals to the relative molecular mass of oxygen. Density is 2. Relative molecular mass is 2 times vapor density. 2 times 16 is 32 over hydrogen is 2, I think, just 2. So if I come down here, the rate for hydrogen over the rate of oxygen is equals to 32, okay, over 2. Good. So let's go with the rate for hydrogen over the rate of oxygen is equals to, this one goes here 1 time, it goes here 16 times. So this becomes the root of 16 over the root of 1. Now, the rate of hydrogen over the rate of oxygen. So this is equal to 16. The root of 16 is 4, and this one is 1. So, that is it. So the rate is, here we have 4:1. Let us proceed. So the rate at which oxygen diffuses is 4 times, remember this is how they call it, M2, is 4 times the rate at which hydrogen diffuses. What again did I say? Of oxygen. And what law do you use to get the answer? The law is Graham's law of diffusion. So it's kind of straightforward. Let's proceed. In 30 seconds, 180 cm cube of oxygen, so the first gas here is oxygen. In 30 seconds, T1 is 30 seconds. 180, okay, V1 is 180 cm cube of oxygen diffused through a porous plate. How long will it take 300 cm cube? V1 here is 300 cm cube. How long? Sorry, this is V2. T2 is the time they are asking of us. How long? We take chlorine. Second gas is chlorine. So oxygen, if I have to. Chlorine to diffuse through the same plate. Vapor density of oxygen is 16. Vapor density of oxygen is 16. And that of chlorine is 36. So remember, relative molecular mass is equals to 2 times its vapor density. So I don't need to deal with the D directly, although I can still use the formula because I still have R1 over R2 is equals to D2 over the root of D2 over the root of D1. So I can apply that directly, but we can still use the relative molecular mass. So R1 over R2 is equals to the root of M2 over the root of M1. R1 here is the same thing as V1 over T1 divided by, which is this, V2 over T2 is equals to the root of M2 over the root of M1. If I cross over here, okay, now, both mass, this have to change. I have V1 over T1 times T2 over V2. This is equals to the root of M2 over the root of M1. Now, what's V1? V1 is 180 cm cube over T1 is 30 times T2 is what we are looking for, we don't know, over V2, V2 is 300. This is equal to the root of M2. M2, this is my 2, 36 times 2. Okay, 36 times 2 is 72. 72 over the root of M1. 16 times 2 is 32. I guess I'm right. Yes, 16 times 2 is that. Okay, so I have 180 T2 all over 30 times 300. 30 times 300, which is 9,000. 9,000. This is equals to the root of 72 divided by 32 is 2.5, so 2.25, so I'm not going to break it down. I have to leave it the way it is to get our destination. So now I have the root of 72 over the root of 32. Now I have to cross multiply. This is what I'm looking for. And I try to summarize it or inside to enter. So I have 180 T2. 180 T2 times root 32 is equals to 9,000 root 72. I am dividing both sides by 180 root 32. Alright? So I go 180 root 32, 180 root 32. So this will go, I'm left with my T2, which is equals to this. Now 900 divided by 180, can it? 180 is 5. So now this is 5 root 72 over root 32. Okay, so now we're going into a different dimension. We're entering sort. This is mathematics. I never thought they're going to take us here. So in sort, we say we never leave a root sign down. So what do? We rationalize. So I have my T2 is equal to 5 root 72 times root 32 over root 32. So times root 32, because you use the root and multiply both up and down. That is the law. So T2 will be 5 root 72 times root 32 over root 32 times root 32 is 32. So T2 will be, now this is 5 times root 72 times 32. 72 times 32 will be 2304. 52304 over 32. Let me see if I can rush that up. I don't want to occupy more space. So this is 2 is equals to, I have to look for the root of that, multiply by 5 and divide by 32. Whatever we have becomes our answer. So the root, where is it? The root of 2304 is equals to 48, funny enough, times 5 is 240, divided by 32 is 7.5. So T2 is 7.5 seconds. To be frank, I never anticipated that we are going to get into sort. So in the course of your going through rate of diffusion, it is pertinent you should have revision on sort fully, like we have seen now. Change of subject or formula, indices, fraction. These topics in mathematics are pertinent for you to be able to solve certain questions in chemistry. Chemistry encompasses a whole lot. Maths, chemistry, physics, they are very, very alike. So I believe with time I'm going to make lectures on these essential topics in mathematics so that we're not going to be found wanting. I think we're just left with one more question, then the other one will be taken as assignment. So let's quickly run through and see what we have. Our last question for the day. So let me take this out. Okay, a gas diffuses out through a porous port at a rate of 47.15 cm3 per second. The gas is unknown. So we don't know what the gas, but the rate at which it diffuses is 47.15 cm3 per second. Under the same conditions, Oxygen. So let's call this one, the gas is unknown. This is oxygen. Under the same condition, this is R1, this is my R2. Oxygen diffuses, under the same conditions, oxygen diffuses at the rate of 16.40 cm cube per second. Calculate the relative molecular mass of the gas. Okay, I think I know where they're coming from. Oxygen is always 32, M2 is 32, and M1 we don't know. So we have R1 over R2 is equal to the root of M2 over the root of M1. R1 is 47.15, R2 is 60.40, is equals to M2. M2 is 32, the root of 32 over the root of M1. That's what we're looking for. Cross multiplication, I will have 47.15 root M1 is equals to 60.40 root 32. Divide both sides by 47.15. This will go with this. So root M1 is equals to this. Okay, let's take that. 60.40 divided by 47.15. 1.28. Let's just call it like that. 1.28 root 32. To remove this, I square both sides. So when I square both sides, I now have my M1 is equals to 1.28 squared. When I square this, I have 1.64. 1.64 times 32. The square of root 32 is 32. So when I multiply this with 32 times 32, I have 52.5. So M1 is equals to 52.5. Relative molecular mass is G mole. So we are going to, calculation wise, we'll stop here, but I give you one as assignment, so you're going to take care of that. The question says, the relative rate of diffusion of a gas as compared with oxygen. So the gas is unknown, which is, you should always have that in mind. The rate, R, which we're looking for, the relative rate of diffusion of a gas as compared with oxygen is 2:1. So the gas is 2, oxygen is 1. Calculate the relative molecular mass of the gas. So if you know your relative molecular mass of the oxygen as compared to the other one, you'll be able to go through. So like I said earlier on, we're going to stop here. But don't forget, we have been able to cover the Boyle's law, the Charles law, the general gas law equation, and this is Graham's law of diffusion. We also have the other ones like Avogadro constant, and so on and so forth. But we're dealing with the essential ones, which you should know and know how they work. So like this is very cardinal in the course of our discussion today. But I guess truly or strongly that we're still going to have more time so that we'll be able to deal with things which are very essential to us. So for the time being, you have a wonderful day or a wonderful night based on the time you're watching it, and see you another time. Thank you.